This question, we have a force time graph, so we'll start out with our Oizerga. The origin is here. So we're dealing with a quadrant 1 and a quadrant 4 situation. The y-axis is force, the x-axis is time, normal units. The intercept, we do have the intercept. The y-intercept tells us is that f is 1,000 at t0. So f0 equals 1,000. And the x-axis tells us that, at about, maybe at about 2 seconds, f becomes 0. We can read force and time. The gradient is delta F over delta T, which is the rate of change in force. And the area is F delta T, which is the impulse J, which is the change in momentum. So we know it's got a mass of 4,000 kilograms. It's traveling in a straight line in a positive direction. So here's the positive direction, negative direction, like so. Engines could be fired so that the force is in the positive or the negative direction. Shows data for the force during one interval. Which of the following is the best estimate in the net change in speed of the spacecraft from 0 to 4 seconds? So we want the change in speed is going to be related to the change in momentum. So delta P equals m delta V. We know the mass is 4,000. And if we want the delta P, well, that is the area. Overall, we could look at this and say, maybe there is a straight line going like this, approximately so. And if so, then we have positive area here and negative area here. So let's say this is 2 times 1,000 is 1/2 base times height, is 1/2 2 times 1,000. So that's 1,000. And afterward, we have 2 seconds and 500. So 1/2 base times height is 1/2 2 seconds times 500. So we have about 500. So we're looking at about 500 is the delta P. Delta V then is 500 over 4,000. 5/40 is about 1/8. So what's curious is that we have a change in velocity of about 0.125, and it's positive. The change in momentum was positive. The mass is a scalar, so you have a positive change in momentum. So that means overall, the closest is about this, choice B, about 0.1, positive 0.1.